Assalamualaikum and hi student! How are you today? Is everyone ready to learn? My name is Nur Shamimi Fariha and you can call me Miss Mimi. Today, we are gonna learn about the types of immunity. But before we go further into it, let me give you a scenario for you to have a better understanding on what we are gonna learn today. You may not know it, but your body is engaged in a never-ending battle. You are literally covered in staph and strep and E. coli and all sort of dubious characters that are intent on using you and your body's many resources to feed themselves, find shelters, and also reproduce as much as they want. But hey, we all gonna make a living, but it is not your job to give these guys a free lunch. So your body has developed a three-part policy toward these shady customers, and its enforcement is handled by your immune system. The immune system is different from all the other systems that we have talked about, and it is not a specific tissue organ system kind of system. Instead, it involves a whole bunch of different tissue groups, organ system, and specialized but widely distributed defense cells. Together, this league of extraordinary substances joins forces to perform all of the defense function your body depends on to keep you alive in an incredibly germy world. Alright, so basically there are two types of immunity, which are active immunity and passive immunity. So what is active immunity? Active immunity means that lymphocytes produce their own antibodies as a response to stimulation by the antigens, while passive immunity means that the body receives antibodies from an external source, and both of these types of immunities can be naturally and artificially acquired. Now, we focus on active immunity. Active immunity refers to the body's immune response to an antigen that results in the production of specific antibodies and memory cells. This type of immunity occurs when the immune system is activated by the exposure to a foreign substance such as a pathogen or vaccine. There are two main types of active immunity, which are natural and artificial. For natural active immunity, this occurs when the body is exposed to a pathogen naturally, such as during an infection. When a person contracts a disease, their immune system mounts a response to eliminate the pathogen, and this response involves the production of antibodies by B lymphocytes, which is a type of white blood cell that are specific to the antigen of the pathogen. Additionally, memory cells are generated during the immune response. These memory cells remember the pathogen and allow for a faster and stronger immune response upon subsequent exposure. Natural active immunity typically provides a long-lasting protection against the specific pathogen. And this can occur naturally, like when you catch the flu or get chickenpox or pick up some nasty bacterial infection, or it can happen artificially, particularly through vaccination. Alright, now moving on to the artificial active immunity. This type of immunity occurs when the immune system is stimulated by exposure to a vaccine containing weakened or inactivated forms of the pathogen, its toxin or specific antigens. Vaccines are designed to mimic the presence of the pathogen without causing illness. When a person is vaccinated, the immune system recognizes the antigen in the vaccine as foreign and mounts an immune response by producing antibodies and memory cells. If the person is later exposed to the actual pathogen, the immune system can quickly recognize and eliminate it, preventing the development of the disease or reducing its severity. Most vaccines are made of a dead or extremely weakened pathogen, and they work on the premise that because a secondary immune response is more intense than a primary response, by introducing a pathogen into your body, you are priming it to fight hard and fast. In the case of typically non-fatal infections like the common flu, this immunity should at least spare you from some of the most severe symptoms. But in the case of more serious disease like polio, smallpox, vaccination can be truly life-saving. This active immunity is an essential aspect of the body's defense against infections and is the basis for vaccination, which has been one of the most effective public health interventions in preventing infectious diseases.
Disease that causes permanent paralysis. We can't cure it, but we can prevent it. Two important tools help to prevent polio, two safe, effective vaccines. One of these vaccines is given with just 2 drops into the mouth of a child. This is called the oral polio vaccine. The other is given with an injection. This is called the inactivated poliovirus vaccine. They both teach children's bodies how to fight off the poliovirus, but they do this in different ways. The oral polio vaccine builds protection in the child's intestine. This vaccine not only protects the child who receives it, but also protects others around the vaccinated child. Several doses of the oral polio vaccine should be given to every single child in places where polio is a threat. The injectable vaccine builds protection in the blood instead of the gut. It helps to boost immunity and keeps countries free from polio.
Moving on to the passive immunity. It refers to the transfer of preformed antibodies or immune cells from one individual to another, providing immediate but temporary protection against a specific antigen. Unlike active immunity, which involves the individual's immune system generating its own immune response, passive immunity involves the direct transfer of immune components. There are also two main types of passive immunity, which are the natural and the artificial. For natural passive immunity, this occurs naturally when antibodies are transferred from a mother to her fetus during pregnancy or to her infant through breast milk. The antibodies pass from the mother to the baby, provide protection against certain infection during the early stages of life when the baby's immune system is still developing. This is why breastfeeding is encouraged, as breast milk contains antibodies and other immune factors that help protect the infant from infections. Babies, for example, naturally obtain passive humoral immunity while still in the womb. They receive ready-made antibodies from their mother through the placenta and later on through breast milk. And that works pretty well for a few months, but the protection is temporary because passively obtained antibodies don't live long in their new body. And they cannot produce effector cells or memory cells, so a baby's own system won't remember an antigen if it gets infected again. Next is artificial passive immunity. This type of immunity is acquired through the administration of preformed antibodies or immune cells that are produced outside the body. This can be achieved through injections of antibodies obtained from individuals who have recovered from a specific infection or through the administration of purified antibodies produced in a laboratory. Artificial passive immunity provides immediate but temporary protection against a specific antigen. You can also acquire these kinds of temporary passive immunity artificially by receiving exogenous antibodies from the plasma of an immune donor. This is what recently saved some doctors and nurses who had contracted the Ebola virus from infected patients. A serum was made from the blood plasma of other medical workers who had been infected and survived. The antibodies help defend the patient from the virus before their own active immunity could identify that particular antigen and start creating their own antibodies. It is not the same as vaccine, which immediately engage your B cells, but it can buy a patient some crucial life-saving time against an infection that would otherwise quickly kill. But B cells and antibodies are only part of the immunity equation. There are plenty of pathogens that quickly worm their way right inside your cell, where they are safer from the humoral response and free to multiply as much as they like. Luckily, your immune system has yet another game plan and new set of players ready to fight that final battle with cell-to-cell combat. Now, we are going to dive into the similarities and differences between two fundamental mechanisms, which are active and passive immunity. The differences between these two are active immunity involves the activation of the body's own immune system, whereas passive immunity relies on the transfer of antibodies or immune cells from an external source. Next, active immunity results in long-lasting protection and the development of immunological memory, whereas passive immunity provides immediate but temporary protection without memory cell formation. Other than that, active immunity requires time to develop, whereas passive immunity provides immediate protection. Despite their differences, active and passive immunity share some common characteristics. Both provide protection against specific pathogens or antigens, and both can be acquired naturally or artificially through medical intervention. Thus, both play important roles in protecting the body from infections and disease. In conclusion, active and passive immunity are two essential mechanisms by which the body defends itself against pathogens. While they differ in their modes of acquisition, duration of protection, and mechanism of action, both active and passive immunity play crucial roles in maintaining overall health and well-being. Understanding the similarities and differences between these two forms of immunity is key to developing effective strategies for preventing and treating infectious diseases. So that's the end of our lesson for today. See you on the next class. Bye!